Hi, welcome to this video on two-step inequality word problems. And so we're just going to look at a couple of word problems that are a little trickier than maybe normal. So here we go. We're going to look at this problem here about Keith. Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 at the end of the summer. He withdraws $25 per week for food, clothing, and movie tickets. He doesn't need gas, apparently. He just needs movie tickets. Anyway, how many weeks can Keith withdraw money from his account before he runs out? Okay. So normally when we do these, well, the first thing I always like to do is, because I'm going to write my inequality like I would write an equation. So my first strategy would be to, after I read it, to identify the variable, which I'm going to say is weeks. So W is weeks. And then I'm going to identify what's the end result of the total. Now, you might be thinking 500 is the total, but 500 is the amount of money he starts with. At the end of the summer, after everything happens, he ends up with 200, or he wants to end up with 200. So that's really the end result. Now he wants to have at least 200. So that means he's okay with more than 200, but he at least is greater than or equal to. Okay, well, if he had 500 to start, then how does he only have 200 to end? Okay, well, that means that he was spending money. So he had 500 and then he was subtracting money out of his account, $25 per week. So now our inequality looks a little different than some of the other ones we've written. And it has that kind of this equation solving strategy where we're subtracting that variable term. And often we don't like it when we have to subtract the variable term. It makes us a little uncomfortable. So the one strategy I have is whenever we're subtracting the variable term, we use keep, change, change. So I'm going to encourage you that when you have it like this and you're subtracting from that constant at the beginning, rewrite it as 500 plus negative 25 W is greater than 200. That way, you're not as confused about what to do with the 500, because when that subtraction symbol is behind the 500, sometimes we like to add 500 to both sides, but we don't want to do that here. We don't want to add 500 because we know he never actually has $700 to spend. So if I added 500 to both sides, I would have 700, and that's not right. We're going to subtract 500 from both sides, and then you're going to get negative 300. And you might be thinking, okay, wait, why is there negative $300? Well, think about it. If he had $500 and wants to end with 200, that means he spent 300. So if he spent 300, that's negative 300. Well, how did he spend 300? He spent 300 because he was spending $25 per week. So if you spend $25 per week and you spend $300 altogether, that means you were spending $25 per week for 12 weeks. So there you go. 12 is my solution. Now, I'm not sure if it's W is greater than or equal to 12, or is W less than or equal to 12. So that part I don't know yet until I get to my graph. So I'm going to put 12 on the number line and put a closed circle because 12 works. And then I'm going to put a numbers greater than 12 on the right, like 14, numbers less than 12 on the left, like 10. And I'm going to check and see which way I think I should graph. Well, there's a greater than symbol here, so let me try a number greater than 12. Let me try 14. Let's do 14, sure. So if I do, I'll do a different color. So $500 to start with minus $25 a week for 14 weeks. Would he still have $200 left over? Well, let's check. So $25 a week for 14 weeks. So that would be $350. And then 500 minus 350 is 150. So that means he would not, see, look, if I write this, that's not true. So 14 is not a solution. So that means my solutions are actually the things that are less than 12. So W is less than or equal to 12. See that inequality flipped because I divided by a negative 25. And so in the end, Keith can spend $25 a week for no more than 12 weeks. Okay, so there. So you can see in this problem here, when we solve this, we wrote the inequality, maybe in a little different way than we normally do. And then when we solved it, the inequality symbol flipped. And then I'm just going to set up number 5 for you. So Joel, his problem is kind of confusing. See, Joel is going to go to the gym, and he has 2 options. He can either pay $50 per month for an unlimited use, as many visits as he wants, or he could pay $12 per month, so less, but pay $4 per visit. So if you weren't going to go that many times in a month, then that would be a good option. But if you're going to go a lot, like every day, maybe you want to do the other unlimited plan. So what we're going to figure out is how many visits would he have to make so that the $50 option is still the better one. So we want the $50 option to be the one that costs less, because we're saying that the other option where you're paying per visit would cost more. So the thing we're trying to find is the number of visits. So months is not the variable. Even though everything's per month, the months are not the variable. We're only considering 1 month at a time. The visits are the variable. So we're going to multiply. We're going to use V for visit. I'm going to say it's $4 per visit plus that $12 fee. So on the left, I have the plan where he's paying per visit and he's paying $12 up front. And then on the right, we have the plan that's the unlimited visits. So it doesn't matter how many visits we need. We don't have to worry about that. So I'll let you solve this inequality. So when we subtracted 12 from both sides and then divided by 4, we got 9.5. Now this is 9.5 visits. So that means on my number line, 9.5 is here, and it's a closed circle. But it doesn't really work that way. It's not like half a visit. Like, I don't know if your body's halfway in the door and halfway out. I don't know what that would mean. So really, we can only have whole visits. Now, if we use 9 here, if I say 9 visits, well, 4 times 9 would be 36, plus 12 is 48. So that's $48 is cheaper than 50. So now the per visit plan is cheaper. But if he does 10 visits, 4 times 10 plus 12 is 52. And now that's more than 50. So then now the unlimited plan is cheaper. So that means we want to graph to the right. So as long as Joel has 10 or more visits, then the unlimited plan is cheaper. So there you go. So there's 2 word problems. Both times I wrote the inequality. Notice that we write the inequality. Then we solve it like an equation. I graphed it, and then I checked my graph to know which way to write the solution. And the final solution that we didn't have is that Joel